Hello, my name is Kunal and welcome to Analytics Mastery Academy. Welcome to video 2 where we will talk about data ingestion and loading. This is the section 2 of the exam. It carries 21% of the total weight, roughly 9 to 10 questions. Together with section 3, ingestion is one of the two highest priority areas for your study time. The core skills this section tests is a given set of requirements, choose the right ingestion method. Volume, frequency, data format, schema stability, governance needs, all of these factors point to different tools. Let's understand each tool so the choice becomes obvious. Let's start with the patterns before we get to the tools. Batch ingestion is the traditional approach. Load a full data set on a fixed schedule. Nightly ETL, end of the day file drops. They are simple, predictable, high throughput for large historical loads. The limitation that you're always processing data from the previous period, not in real time. Incremental loading is efficiency upgrade. Instead of reprocessing everything, you track what's already been loaded and process only new data. Copy into an autoloader both can do this. This is the dominant part for production data engineering. It's faster, cheaper, and more scalable than full reloads. Streaming ingestion is continuous. Process the data as it arrives with latency measured in seconds or minutes rather than hours. Databricks uses Spark structured streaming as its streaming engine and Delta table as the streaming sink. Common sources include Kafka, Kinesis, and Azure Event Hubs. Microbatch streaming is Spark's model. Instead of processing truly one event at a time, it batches a small window of events and processes them together. This gives you near real-time latency with efficiency of batch processing. For the exam, the key is matching the pattern to the use case. Near real-time points you towards the streaming or microbatch. Daily data drop points you towards the batch or incremental, and continuous file arrivals from an external system points you towards the autoloader. Copy into is one of the most elegant commands in Databricks SQL. Let me show you why. What makes copy into special is that it's idempotent. When you run copy into, Databricks tracks which files have already been loaded into the target table. Run it again, it only loads the new files. Run it 10 times on the same path, only new files are processed each time. This means you can safely put copy into in a scheduled Lakeflow job without the fear of duplicates. It's inherently exactly once for file ingestion. Autoloader is Databricks' answer to large-scale continuous file ingestion. If copy into is the reliable workhorse for batch, autoloader is high-performance option for the streaming file ingestion. Autoloader uses a special Spark source called cloud files. There are two discovery modes, and this is exam critical. Directory listing mode pulls the cloud storage directory on a schedule, listing all files and finding new ones. Simple to set up, works everywhere, but at scale, millions of files, the listing itself becomes expensive and slow. File notification mode integrates with cloud event notification services like S3 event notifications, Azure Event Grid, GCS PubSub. When new file lands, the cloud service sends a notification and autoloader picks it up immediately. No polling, no listing. This is the production grade choice for high volume scenarios, faster and cheaper at scale. Autoloader can infer the schema from the sample of files and store that inferred schema in a schema location. This makes restarts safe. It doesn't reinfer from scratch. When the new column appears in the data, you have three options. Fail fast rejects the new data, which is the strictest mode. Rescue puts unrecognized columns into a rescued data column, allowing evaluation without breaking the pipeline. And merge adds the new column to the target table schema automatically, which is a true schema evolution. Autoloader uses a checkpoint to track which files have been processed. If the streaming job restarts after a failure, it reads the checkpoint and continues from exactly where it left off. No duplicates, no data loss. Lakeflow Connect is Databricks' native collector platform for enterprise data sources. Think of it as Databricks' answer to Fivetran or Airbyte, but fully integrated into the platform. Standard connectors are pre-built integrations for common software as a service and database sources for things like Salesforce, ServiceNow, Google Analytics, MySQL, SQL Server, etc. Configuration is done through the UI in the Databricks workspace. No custom code is required. Managed connectors take it a step further. Databricks manages the connector infrastructure, handles scaling, monitors health, and automatically recovers from the errors. When you need guaranteed delivery and SLA for critical enterprise data, managed connectors are the choice. Partner connectors are third-party integrations certified by Databricks. Companies like Fivetran have connectors that plug into Lakeflow ecosystem while being operated by the partner. Lakeflow Connect handles JSON, XML, and nested data natively. It can flatten nested structures or preserve them as struct columns in Delta depending on your configuration. All data ingested via Lakeflow Connect lands in Unity Catalog governed tables. Lineage is tracked from source system to the Delta tables automatically. Choose Lakeflow Connect when the source is a supported software as a system or enterprise application like Salesforce, SAP, or Workday. When you want no-code setup and Databricks managed operation, when governance and lineage tracking from the source are required, and when you don't need custom transformations logic during ingestion. Choose Lakeflow Connect. So not every data source has a pre-built connector, right? For relational databases and REST APIs, you write the ingestion code yourself, usually in a Databricks notebook. The key performance concern with JDBC is that default Spark reads the entire table in a single partition, one task, no parallelism. For large tables, you must specify a partition column, a numeric column to split on, a lower bound and upper bound, the range of values and the number of partitions and how many parallel readers. With this set, Spark splits the read into multiple parallel tasks dramatically faster for larger tables. This decision framework is the core of the section 2 exam questions. The scenario will give you constraints, volume, frequency, governance, schema stability, and you match those to the right tool. Practice this mapping until it's automatic. Use autoloader when files land continuously in cloud storage. Volume is large, millions of files. Schema may evolve or you need streaming semantics. Use copy into when you have small to medium file set, a batch only schedule, a stable schema, great for manual or scheduled backfills. Use Lakeflow Connect standard when you need no code connector to supported database source with moderate ingestion frequency. Use Lakeflow Connect managed when you need guaranteed delivery, SLAs, and Databricks managed infrastructure for critical enterprise data sources. Use JDBC or REST when no pre-built connectors exist or you need custom transformation logic during ingestion. Always schedule with Lakeflow Jobs. And regardless of ingestion method, always land data into Unity Catalog governed tables for lineage, auditing, and access control. So here is the section 2 summary. Copy into is idempotent batch loading via SQL, tracking processed files automatically. Autoloader uses the cloud file source with notifications enabled for scale and a schema evolution mode for drift. Lakeflow Connects gives you enterprise no-code connectors, standard versus managed based on the SLA needs. JDBC uses number of partitions plus partition column for parallelism and always use Databricks Secrets. And most importantly, always land data into Unity Catalog governed tables for lineage and governance. In video 3, which is the next video, we will tackle data transformation and modeling, the biggest section of exam at 22%. See you there. Thank you.